Hello everyone. Again, sorry I can't be there today, but you should have come to class having already done the 4.1 and 4.4 notes. And so my expectation for today is that we're going to do a quick little review together that you're following along and adding to your notes as we go. And then I want you working on the 4.1 and 4.4 practice problems. And if you get this done early, then you should be working on your corrections for any of those Unit 3 tests. So I'll make sure that I leave this answer key and the keys to those Unit 3 tests with the sub, so that you can check your work and you can use them to help you get those corrections done. But I want there to be lots of collaboration, like you're working with your group, you're talking to other groups even as you go through and you as you go through and you work on your practice problems and as you do your corrections. You should be working together and then using the key more just as like checking if your knowledge is correct. I also have new seats for you today, and so I'll leave those new seating charts with the sub as well. So please take a moment and check that new seat, find that spot, sit down, say hello, introduce yourselves to the new people in your group, and make sure that everyone knows each other's names before you dive into all the new stuff. Okay, great. So, topic 4.1, I'm looking at page 5 right now, was Introduction to Chemical Reactions. Again, this is just like old info for you. There's nothing new that you needed to know there. And then the difference between a physical and a chemical change, which again, this should all be just old information that we learned back in Gen Chem or Honors Chem. So all I want to do with you right now is go to page 7 and let's just jot down some like overall ideas that I just want us to remember before we do the practice problems, okay? So first off, a chemical change requires the breaking and or formation of chemical bonds, okay? So requires so it requires the breaking and / or formation of chemical bonds. Okay. This is different than a physical change. A physical change cannot involve the breaking and or formation of chemical bonds. Now, we could add or take away energy to increase or decrease the strength of IMFs, like the attraction between molecules, but the chemical bonds themselves are not breaking. So a physical change, like during a physical change, IMF strength can change, but chemical bonds cannot change. Sorry if you hear my daughter's movie in the background. Chemical bonds cannot change, okay? So what would this look like as far as a formula goes? Like a chemical change, here's an example. What if we have NaCl aqueous, and this is going to react with like a silver. So Ag and then 2, or no, Ag, sorry. Yes, Ag2O. Ag2O, a silver oxide. So the sodium chloride is going to react with a silver oxide. They're both aqueous. And then here's what's going to happen. These bonds are going to break and new bonds are going to form. And the silver is going to go with the chlorine. So we're going to get this like AgCl that doesn't like to dissolve. It's going to be a solid. And then we're going to have this sodium oxide, this Na2O. That's going to be aqueous. Okay? This is an example of a chemical reaction. We also need to balance this chemical reaction. We'd want a 2 there and a 2 there, and then I believe this is balanced. And so when chemical bonds break and new items form, that's when we have a chemical reaction. Yes, we also saw some phase changes, but it wasn't primarily like all by itself. It wasn't only a phase change. Phase changes all by themselves are a physical change. Phase change. That's really common when we see a physical reaction. So, for example, what if we took table salt again, NaCl solid, and we heat this up enough that it becomes a liquid? Okay, that alone is not a chemical change. Truthfully, it's not the best example, but let's think of another one that I know would work well. What if we take trying to think of one that you would be familiar with. Okay. What about not the combustion of gasoline, but just like liquid to vapor? So let's okay, so C8H18. Just look that up. This is octane, and we're familiar with our liquid octane, but then you might have filled up your tank before and you get that like that gas smell. That's because some of the liquid molecules have gained enough energy that it decreased the IMF attraction and it became a gas. C8H18 gas. That's also a physical change. Okay. The other thing that I know it's written up above, like I understand that, but you do really need to know these 5 signs of a chemical reaction. Okay, so I do want you to know those 5 signs of a chemical reaction. That those 5 signs, that if there's just one, yeah, it might be a chemical reaction. If there's 2, I can pretty much say that there's a chemical reaction. Like the more signs that there are, then the higher the likelihood it is that it's a chemical reaction. Okay, so the answer key to this should be at the front, okay? Ones that I think that you might need a little more explanation, I've put some notes in, and then there is one that I need to show you guys. If you'll go to, it's one of the free responses. It's number 11, part C, there is a typo. So just a heads up there is a typo, but if you can't see it, like check the key and I'll show you. And then D, part 2, we need to cross that one out. We need to skip it. It's an old question. It's back when we thought that hybridization also happened with the D block, but now we know that's no longer true. So they wouldn't ask you a hybridization question that is more than an sp3, and that's what's going on here. So you can skip that one. But the rest, I want you guys to do. So again, you've added these notes. Now you're going to work on the practice problems with your new group. Once this is done, Then you feel free to move seats and go with your old partners to do corrections on the partner test, or work really with whoever you would like in class after this is done, to do corrections on any of the Unit 3 stuff. If you guys have questions and need help with anything, guys, don't hesitate to email me. I'll be at that writing workshop thing for the test, but I should be able to respond to emails. So, okay, I think that's it. All right, be the amazing students that I know you can be, and then I will see you guys all next week.